This is SpaceTime, Series 28, Episode 151, for broadcast on the 24th of December 2025. Coming up on SpaceTime, NASA's Mars Perseverance Rover finally moving to a new location on the rim of Jezero Crater. Using microbes to make space fashion. Looks like those one-design silver spacesuits from the sci-fi movies of the 50s won't be making a comeback after all. And the Expedition 73 astronauts returned safely to Earth following their 8-month stay aboard the International Space Station. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Well, after nearly 5 years on the surface of the Red Planet, NASA's Mars Perseverance Rover is finally moving on to a new location on the rim of Jezero Crater, which has been dubbed Lac du Charm. The 6-wheel car-sized mobile laboratory has travelled over 40 kilometres across the crater floor, climbing the river delta sediments and along the crater rim. As well as continuing with its scientific mission, managers have been evaluating the rover's durability and testing its subsystems to see how they're coping. Like its older counterpart rover Curiosity, which has been exploring Giles Crater on a different part of Mars since 2012, Perseverance has had to deal with extremes in temperature, dust and terrain. NASA's Jet Propulsion Laboratory in Pasadena, California, which built both rovers, has been testing an identical counterpart to Perseverance back on Earth in order to tell how well its Martian twin is dealing with its environment. And the good news is, JPL's just certified the rotary actuators which turn the rover's wheels for another 60 kilometres. Next, it'll be brake testing. It's sort of like a full rego check for the rover. In fact, over the past 2 years, engineers have been extensively evaluating nearly all the vehicle subsystems in the same way. And their conclusion is that they believe Perseverance will be able to keep operating until at least 2031. Perseverance Deputy Project Manager Steve Lee from JPL says the tests are showing the rover is in excellent shape. Perseverance has been driving through Jezero Crater, the site of an ancient lake and river system, where it's been collecting scientifically compelling rock core samples. And back in September, the rover grabbed a sample of a rock which had been nicknamed Shayava Falls, which scientists believe may contain a potential fingerprint of past microbial life. In addition to a hefty suite of 6 scientific instruments, Perseverance has more autonomous driving capabilities than past rovers, including an autonomous planning tool known as Enhanced Autonomous Navigation or ENAV. The software looks up to 15 metres ahead of the rover for potential hazards. It then, all by itself, chooses a path without obstacles and tells Perseverance's wheels how to steer there. Engineers at JPL meticulously plan each day of the rover's activities on Mars. But once the rover actually starts driving, it's on its own, and sometimes has to react to the unexpected obstacles in its terrain. Now, past rovers could do this to some degree, but not if the obstacles were all clustered near each other. Also, they couldn't react as far in advance, and that resulted in the vehicles driving a lot slower while approaching sandpits, rocks and ledges. In contrast, ENAV's algorithms evaluate each rover wheel independently against the elevation of the terrain, trade-offs between different routes, and keep in or keep out areas marked by human operators for the path ahead. In fact, more than 90% of the rover's journey on Mars has relied on autonomous driving, making it possible to quickly collect a diverse range of samples. Meanwhile, a new study reported in the journal Science claims 3 samples collected by Perseverance in a geological area known as the Martian unit, which is along the inner edge of Jezero Crater, may be useful for showing how ancient rocks from deep inside the Martian interior interacted with water in the atmosphere when they reached the surface, in the process helping to create conditions which would have been supportive for life had it ever existed there. Between September 2023 and November 2024, Perseverance ascended some 400 metres along the Martian unit, studying rocks along the way, especially those containing the mineral olivine. Scientists use minerals as timekeepers because crystals within them can record details about the precise moment, conditions in which they formed. Jezero Crater and the surrounding area holds huge reserves of olivine which form at high temperatures, and typically deep within a planet. and so offer a snapshot of what's going on in a planet's interior. Scientists think the Martian unit's olivine was made in an intrusion, a process where magma pushes into underground layers and cools into igneous rock. In this case, erosion later exposed that rock to the surface, and there it could interact with water from the crater's ancient lake system and with carbon dioxide, which was abundant in the early Martian atmosphere. And these interactions form new minerals known as carbonates. And carbonates can preserve signs of past life, along with clues as to how Mars's atmosphere has changed over time. In fact, it was the combination of olivine and carbonate which was a major factor in NASA's decision to choose Jezero Crater as a landing site in the first place. Together, the olivine and carbonates record the interplay between rock, water and atmosphere inside the crater, including how each changed over time. The Martian unit's olivine appears to have been altered by water at the base of the unit, where it would have been submerged. But the higher Perseverance went, the more the olivine bore textures associated with magma chambers, like crystallization, and fewer signs of water alteration. Now, as Perseverance leaves the Martian unit bound for Lac du Charm, mission managers will have a chance to collect new olivine-rich samples and compare the differences between the two areas. This is SpaceTime. Still to come, using microbes to make space fashions. And the Expedition 73 crew have returned safely to Earth following an 8-month-long tour of duty aboard the International Space Station. All that and more still to come on SpaceTime. A new project that fuses fashion and science is set to send bacteria into space, and the outcome could create radiation-sensitive fabrics capable of preventing skin cancers on Earth and protecting space explorers on the Moon. To achieve all this, scientists have teamed up with fashion designers to make fabrics painted with specially designed dyes made from different types of bacteria. When this multi-layered, multicoloured fabric's exposed to radiation and ultraviolet light, the dyes in each layer fade, revealing the layer below and leaving visible evidence of the level of radiation they've absorbed. In the future, fabrics painted with the dye could be used in space missions, helping space explorers determine at a glance if they've been exposed to dangerous levels of radiation. And they could also be used here on Earth in clinical settings, providing radiation-sensitive scrubs and aprons. In fact, it could even be used in everyday fashions to create colour-changing clothes to help people monitor their exposure to sunlight, thereby helping to reduce the risk of skin cancer. The study's lead author, Giles Ballet from the University of Glasgow, says exposure to radiation breaks up the pigments in the bacteria, in the same way similar exposure to radiation in humans breaks up DNA. For the bacteria, it means a reduction in their colour saturation, but of course for people, it means greater risk of genetic mutations and cancers. So far, the authors have developed fabrics using 6 different bacteria-based colours. There's a red, a yellow, a type of pink, a blue and an orange. Harmless bacteria naturally produce different pigments for various protective purposes. The bacteria are then applied to the fabric using specialised needles and 3D printing techniques, in the process creating very precise patterns and layers. When the bacteria die, they leave behind only their protective pigments, in the process creating a stable colour-fast fabric that responds predictably to radiation exposure. Now, once in orbit, regular images of the fabric during the year-long space mission will show the changes in the colour of the pigments as the satellite is exposed to months of radiation in low Earth orbit. And if this mission goes as planned, the authors hope to launch a more ambitious project which will take a larger piece of fabric to the surface of the Moon in 2028. And that would be the first Scottish-built hardware to reach the lunar surface. The patch would be equipped with a dedicated camera and microscope to enable mission managers to broaden their understanding of how the dye reacts to long-term exposure to the Moon's harsh radiation environment. And the data they collect about the radiation exposure patterns could then be used to help support safety measures for future manned lunar missions. This report from the University of Glasgow.
We started the project with a really small pot of money from the Impact Acceleration account from the University of Glasgow to investigate how to put my technology into the fashion garments of Katie Tobing. We wanted to bring space engineering, microbiology, and artists together to try to do some outreach in a different manner. But on the way to that, we actually invented a brilliant new technology, first of a kind, that is allowing us to have a two-dimensional dosimeter. You could cover full spacesuits with this fabric, and that will actually measure the radiation, not just on one point like it's done now, but on the full body. And also direct visual feedback for the astronauts to understand what dose of radiation they've been exposed to. And that really leads us also to applications on Earth for the staff at NHS in healthcare, but also for workers in the nuclear industry. The project is centered around the fact that small bacteria produces pigments to protect themselves against radiation.
Part of the work that we do is pigmented bacteria that is used to dye textiles in a more sustainable way. So instead of using synthetic dyes that contaminate water streams, bacteria can be used as a natural alternative. The same way humans produce melanin or different types of proteins that make our hair curly or straight, bacteria can produce these compounds that then create this pigment. So, for example, an orange bacteria has keratin. Carrots also have keratin. It's what makes them orange. So it's a chemical compound that the bacteria produces, and that is the color that we're using.
You can stack that up. So you will have different layers with different painting for each layer. And when you expose all of that to outer space, this will be bleached by radiation. Cosmic radiation, X-ray, UV. And so the layers will bleach one by one, revealing the layers below. And so if you're taking a time lapse of it, you will be able to see color fading, shape changing, everything like that.
So I'm working on creating the design of the colors of the bacteria on the fabric, and especially the fading element, because the more fade we get, the more we can understand the effect of the radiation on the bacteria. What I want is a result which is visually interesting. I don't want to say beautiful, but visually interesting, but also functional and useful, so we get some data from it. And that's what I'm really trying to balance.
We are working with a startup in Edinburgh called Spinning Around. They are hosting this experiment with us. And so the idea is that we're going to send this brick like that. Everything will be mushed together inside the rocket. It's going to be in space in February 2026 and released for its own mission in March 2026. And so once it will be released by itself, we will have a camera inside the main part of the spacecraft imaging our fabric made with pigments. And the idea is if we are able to get good enough data on this mission, then we'll be able to send a larger sample, a larger experiment on the surface of the moon to prepare the exploration of the moon by the new astronauts. This is really possible thanks to this amazing bioprinter, which is here at the Mechanobiology facility at the Advanced Research Centre.
And in that report from the University of Glasgow, we heard from space technology lecturer Giles Ballet, microbiologist Kira Tucker, and fashion designer Katie Tubbing. This is SpaceTime. Still to come, the Expedition 73 crew returned safely to Earth following an 8-month-long mission aboard the International Space Station. And later in the science report, a new study finds that humans have been making and using fire for at least 350,000 years earlier than previously thought. All that and more still to come on SpaceTime. The Expedition 73 crew have returned safely to Earth following an 8-month-long tour of duty aboard the International Space Station. Their Soyuz MS-27 capsule touched down on the frozen Kazakh steppes just 3 hours after departing from the orbiting outpost. Their replacement Expedition 74 crew arrived on station 2 weeks earlier aboard their Soyuz MS-28 spacecraft. And that may well wind up being the last manned Soyuz launch for quite some time, after their rocket's jet blast destroyed key structural components of the launch pad during the liftoff. The Russian Federal Space Agency Roscosmos says repairs to the facility could take over a year, and Moscow has no other launch complexes designed to handle manned spacecraft. Roscosmos has already dialed back their manned launch frequencies to just 1 flight every 8 months due to Kremlin budget cuts. That compares to NASA's manned space program, which has been flying crews to the space station every 6 months using SpaceX Dragon spacecraft under the agency's Commercial Crew program. While on station, the Expedition 73 crew were involved in more than 250 experiments. These included studying the behaviour of bioprinted tissues containing blood vessels in microgravity. That'll help advance space-based tissue production to treat patients on Earth. They also evaluated the remote commanding of multiple robots in space for the Surface Avatar study. That could support the development of robotic assistance for future exploration missions. And they worked on developing in-space manufacturing of DNA-mimicking nanomaterials, which could improve drug delivery technologies and support emerging therapeutics in regenerative medicines. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has shown that people who experience intense and prolonged grief after the loss of a loved one are more likely to die over the following 10 years. A report in the journal Frontiers in Public Health looked at 1,735 people in Denmark who had recently lost a partner, a parent, or a close loved one. They studied these people over a 10-year period to see how the intensity and duration of their symptoms of grief impacted their physical and mental health. The authors found that 6% of the group experienced high levels of grief symptoms, and those people had an 88% higher risk of death compared to those with lower grief symptoms. People experiencing intense grief also used more healthcare services, especially around therapy and medications for mental health, although this link disappeared by about 8 years. Archaeologists have found that humans were already making and using fire 350,000 years earlier than previously thought. The authors found baked clay, heat-shattered flint axes and pieces of pyrite, a stone used to create sparks, in a disused clay pit in England dating back some 400,000 years. The authors were able to prove that the clay was subjected to temperatures of more than 700 degrees Celsius on repeated occasions at the same location. And that indicates a campfire or hearth being used by people on several occasions, and therefore it wasn't simply a case of burning due to wildfire. The findings, reported in the journal Nature, suggest the site wasn't made by Homo sapiens, but more likely by some of the oldest Neanderthal groups. The authors believe the discovery is clear evidence that hominids were creating and controlling fire 400,000 years ago, and that has implications for human development and evolution. A new study shows that 1 in 10 boys between the ages of 10 and 18 meet the clinical diagnostic criteria for computer game addiction, also known as internet gaming disorder. The findings, reported in the journal Addiction, also indicate that while boys are more easily hooked on gaming, just 1 to 2% of girls develop this kind of problem. The study's authors say the reason is simply a case of boys being far more competitive than girls. Previous research has already shown that the brain releases dopamine in its reward centre when you do activities you enjoy, like gaming. This release increases when you expect a positive experience and when the expectation is actually met. The new findings are based on a study of 812 young people in the city of Trondheim, Norway, who were followed up 5 times from the age of 10 to 18, with participants roughly equally divided between boys and girls. The authors found that the proportion who are heavily involved in gaming increases from the age of 10 to about the age of 16, but it then starts to fall again by the age of 18. Well, of course, tomorrow's Christmas, and if, like me, you're a last-minute shopper, well, maybe the thing your loved one really wants is a new printer. Stop smiling, we're being serious here. Quite honestly, if you are looking for a printer, you need to ask yourself a couple of questions. How often will you be using it? And what features do you really need? With a quick guide to buying the right printer, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
The salesman was saying that if you ran out of ink, you just buy a whole new printer. But the problem with that is that new printers come with starter cartridges that only have a small amount of ink inside, sort of enough to get you going and do a few prints, and then you buy brand new ink cartridges which have the larger amount of ink inside, but are still quite small compared to the amount of pages you can get from a laser printer with toner, which is, powdered black ink. And if you buy a color laser printer, the cost of the cartridges can be quite expensive compared to just buying a cheap and simple inkjet printer. But with a color laser printer, the toner never dries up because it's powder, whereas with ink cartridges, the ink can dry up. Now, we do have the problem of the smaller ink cartridges having ink that can cost more than a bottle of Dom Perignon if you were to buy the same volume. So the ink is quite expensive. And although you do have third-party inks that you can buy from various stores, the printer companies always say that they have developed inks that lubricate the system and don't clog things up, and they're designed to work properly. But I've personally noticed that if I've got one of these ink tank, eco tank printers from Brother or Canon, I mean, they're fantastic, but they're designed for you to have a family with lots of kids printing, or to be used in offices, small offices and businesses. If you're just going to print once or twice a year, you either get yourself a black and white laser printer, but if you need color, and it's only very rarely, well, if it's rarely, you can go to an Officeworks or one of the stores that has printers there that you can just bring a USB stick. But the other option, of course, is just to buy a cheap inkjet printer, because if it does clog up, well, you can always have, brand new cartridges to hand. And the printers do have cleaning cycles. But this is where I was harking back to the fact that you have these eco tank, ink tank type printers that can have a year or two's worth of ink inside, depending on how much printing you do. But they're designed to deliver that, year long, at least up to 2 years with Epson level of printing on a constant basis, because they have these ink tanks that you buy these little bottles of ink at about $20 a pop for each color, pour them in and just keep going. You don't have to buy the little ink cartridges that have the heads there. But I have noticed that those, if you don't use them, because I'm a bit like you, I only print rarely, if you don't use them for a long time, then they tend to clog, and then you've got to run 20 or 30 cleaning cycles to get rid of the lines. So if you're just an everyday individual user that prints rarely, well, you just buy one of these cheap printers. I've seen them for sale as little as $20 sometimes on sale at some of those big, cheap department stores, because they're getting rid of old models. And if it does play up, it can be easier just to go and get a whole another one, a new one of those, plug it in and off you go. But if you do have a more serious amount of printing to be done, and you've got a family with kids, or you have a small business that's always printing stuff, then definitely the best way to go is to get one of these eco tank / ink tank type printers from Canon and Brother, which do a fabulous job. Epson as well. They do this fabulous job of delivering lots of ink at a low cost. You do pay more up front for the printer. You'll be paying $200, $300, $400, $500 depending on, whether it has a printer and a scanner and a multi-sheet feeder and double-sided printing, and, there's various models out there. So for higher volume use, definitely one of the eco tank style printers. Individual use, just one of the cheap ones. And if you feel like buying a spare cartridge, off you go. And if not, you've always got the ability to go to Officeworks or a Best Buy if you're in the US, that sort of place, where they have laser printers that you can bring a little USB stick in and pay whatever it costs per page, get your printing done.
That's Alex Zaharov-Reutt from TechAdvice.life. And this is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.